Okay. Okay, next study, dipole-dipole attractions, right? Dipole-dipole interactions. So, what's dipole-dipole interaction? The interaction between two polar molecule, right? Okay, the interaction between two polar molecule. Polar molecules mean what? Having permanent dipole moment, right? Having permanent dipole moment. For example, HCl. What? Delta plus, delta minus. No dipole moment, no permanent dipole moment, but there will be a momentary dipole moment because of the movement of this electronic cloud. Right? Sometimes the electronic cloud may be asymmetrical. Right? Sometimes only a few minutes, right? Only a few microsecond lag, right? It will be non-polar because of polar because of random magnitude. So that type of this dipole attraction, dipole moment is called what? Momentary dipole moment. Of another name, instantaneous dipole. Instantaneous dipole, and also it can be induced by a charge. It can be induced by a charge. Then also it will become dipole. That is called induced dipole. Right? So there may be an induced dipole or an instantaneous dipole, but not a permanent dipole. The term just dipole is referred to permanent dipole, right? This is permanent dipole. So molecules have a permanent dipole moment are called polar molecules, and between those polar molecules you can find an attraction. That attraction is called dipole attraction. Right? Why dipole? That there are two words. Ion dipole attraction. Dipole attraction. Dipole induced dipole. That two word means what? Yeah, between that and that. Right? So between this and this. Right? Okay. Dipole attraction means what? Between a polar molecule and another polar molecule. Right? Dipole attraction. Dipole induced dipole. What? Between a dipole and between a polar molecule and non-polar molecule. Okay. Okay. Let's take HCl. HCl. This would be like delta plus, delta minus. HCl. Delta plus, delta minus. And yeah, you can easily see that there should be a attraction between this delta plus and delta minus. Right? There are two poles, delta plus, delta minus. That's why this is called a dipole. Dipole, two pole. Right? And one negative pole of this molecule attract positive pole of other molecule, and this type of attraction is called what? Dipole attraction. Right? Okay. You see beryllium chloride. Beryllium chloride. Okay. Each bonds are polar, but the resultant molecule, overall molecule, is non-polar. So this is what? Polar molecule or non-polar molecule? It's non-polar molecule. Between two beryllium chloride, there is no dipole attraction, even though they contain delta minus and delta plus. There are delta minus and there are poles, dipoles, but resultant dipole moment is 0. So it cannot attract another molecule because inside inside itself, it will cancel each other inside itself. Right, so there is no attraction with no dipole attraction with another molecule. Okay. Okay. Yeah, and see. HCO. What's this? Delta. Delta plus N, delta minus, delta minus oxygen. Delta minus, delta plus. When they come close together, what will happen? Yeah. There will be an attraction. That attraction is called what? Dipole attraction. Why dipole? Because this is a dipole and it's also a dipole. So the attraction would be what? Dipole attraction. Right? Okay. Okay. Note it down. Okay. You should note it down in this picture here. In this page, this gap, and this picture in this gap, right? And sorry, I'll draw it another one. SO2, SO2. SO2. SO2 is a polar molecule or non-polar? It's a what? Polar molecule. Delta plus, delta minus, right? If it is linear, okay, then you can think as it's a dipole, permanent dipole, not right? Right? But the molecule is what? Angular. That's the resultant dipole moment downward. Right? Okay. Let's put this lone pair downward. This is delta minus, and sulfur delta plus, sulfur is delta plus. Between two SO2 molecule. Delta minus, delta plus. Okay. How the attraction, dipole attraction would be? How the dipole attraction would be? How? Like this. This delta minus and delta plus. The attraction should be between the delta plus positive pole of this and the negative pole of other one, right? It should be like this, right? The attraction should be point out like this. Okay, this is the way the attraction should be shown between this delta plus and lone pair of the delta minus. I'll tell you why. Better, it should be between the lone pair of here, lone pair of delta minus this delta plus, right? There should be always dipole attraction should start from a lone pair of delta minus, and here there will be no lone pair. Sometimes there may be lone pair like this, but you have to show that lone pair downward. Don't show it here, or sometimes slightly here, like here, somewhere here, not here, right? Somewhere here or downward, anywhere, not here. There is no attraction between a lone pair and another lone pair. Okay? The attraction should be lone pair from delta minus and what? Atom. This is electron deficient atom, delta plus. So directly towards atom. Okay. I'll explain you why. Okay. Draw it.